So welcome all for our next session. In this, we'll be studying the semi-float, full float, and three-quarter float axles in detail. So, as you know, you must have seen my previous two videos that are specifically dedicated for the classification of automobile axles. In automobile axles, in those videos, we have studied one segment, one classification, which is according to axle, shaft, and housing arrangement. And in that, we can find these three particular types, which are semi float, full float, and three-quarter float axles. So, before we proceed to the construction and other details of these three axles, I would like you to take through the functions of automobile axles. So automobile axles primarily perform three functions. The first and foremost important function is as a structural member, and this is a primary and compulsory function of the automotive axle. Automotive axle is the system that is located between vehicle chassis and ground. It is attached to chassis at one side and is grounded through wheels and tires on the other side. It carries vehicle load. So the axle is the system which transfers the vehicle load to the ground through wheels and tires. And this is the one of the important functions of the axles. The next function is that it performs is as a part of transmission system. This is primary and optional function. Automotive axle is the system that is final reduction within the automobile transmission system. So sometimes in addition to the structural member, it also performs as a part of transmission system. And third important function is as a part of steering system. This is also a primary function and optional. Apart from a structural and transmission system, automotive axles are also part of vehicle steering systems, particularly when they are front axles. So, what are the different functioning situations for automotive axles out of these three important functions that we saw in the previous slide? So, considering compulsory and optional functions of axles, any axle is supposed to work under one of below mentioned functioning situations. So out of the three functions, there arise four different situations under which axle are supposed to perform its duty. First is as a structural member of the vehicle system only. So there are some axles which will be performing their duty as a structural member only and nothing else. Second is in some cases, in addition to be a structural member, the axle assembly is also a part of transmission system. That is, it contains the differential gearbox and it gives the speed difference for left side and right side wheels. Third situation is in some cases, in addition to be a structural member, it is also a part of steering system. So when the axle is located at front, it carries the load, and in addition to that, it helps the vehicle for steering. It its wheels will turn as per the steering system design and they will perform vehicle turning function. And the fourth is in some cases, in addition to be a structural member, It is also a part of transmission system as well as steering system at the same time. So there are certain situations where the axle is a structural member. It is part of transmission system. That means it has a differential gearbox also, and it is a part of steering system also at the same time. This will particularly happen when the axle is at front and it is the live axle. So this is what we have seen. Now, types of loads on axle. Normally, automobile axles are subjected to three types of loads. One is the vehicle weight, second is the torque transmission, and third is side thrust that generally comes during cornering of the vehicle. So these axles can be distinguished on the basis, semi-float, full float, and three-quarter float. These are the three types which are distinguished on the basis of axle construction, load distribution, type of bearings used, and number of bearings used. So these are the four main distinguishing features through which the axle type becomes like semi-float or full float or three-quarter float. How that happens, we'll see in the next slides. So first is the semi-float axle. So how the construction of semi-float axle is? In this type of axle, a bearing is placed. A bearing, here you can see this is the bearing. A bearing is placed in between the axle shaft and the casing. So this is the outer side and this is the casing of the axle. This part here located, this is the bearing, and at the center of it there is a axle shaft. The axle shaft flange is coupled with wheel. So many times on this flange there is a wheel rim located here, and to wheel rim there are tires attached at the end of it. So typically these axles use ball bearing and it is one per side. So most often this type of axles use ball bearings and one bearing per side it is used. So to the next slide, and we'll see how the load distribution takes place. As we can see in the diagram that is on the previous slide, the vehicle weight is taken by the axle shaft, side thrust is taken by the axle shaft, and the torque is taken by the axle shaft. So all kinds of loads are taken by axle shaft alone. As we saw in the previous to previous slide, there are three types of loads that are normally coming on the axle, that is vehicle weight, torque transmission, and side thrust. So here we can see that all these three kinds of loads are taken by axle shaft alone. And this type of construction is called as semi-float axles. So what are advantages of this type of construction? First, it is simple in construction. Second, it is cost effective. Third, it contains less number of parts. Fourth, it is simple for assembly. And fifth, ball bearings are also cheaper as compared to paper roller bearings. So these are the advantages of the semi-float type axles. So what are the disadvantage of semi-float axles? First, axle shaft failure result into failure of vehicle load support as well as torque transmission. So complete loss of function. So as the axle shaft alone is performing all the necessary duties, that is taking the vehicle load, transmitting the torque and taking the side thrust at the same time. So if the axle shaft is failed, all the functions that are performed comes to end and a complete loss of function is observed in this case. Second, axle shaft failure may result into separation of wheel from vehicle. This is serious safety concern. So in this case, if the axle shaft is broken into two pieces, it is possible that the vehicle wheel will get separated from it, and this may pose a serious threat to the safety of the vehicle occupants. Third is, since axle shaft alone carries all type of loads in this design, generally shaft diameter required for same torque values is larger as compared to other types. So in this case, since all the kinds of loads are taken by the shaft alone, you need to design a robust shaft as compared to the other designs. So what are the major application areas of this type of axle? So major light application vehicles use this type of axles. So wherever there is a light application vehicle, I mean light uh, vehicles where there is no heavy loads, there this type of axle is predominantly used. Let us move to next type. This is full float axle, and the construction of this axle in this type, a separate hub is mounted over axle casing with two taper roller bearings arranged back to back. The axle shaft is placed inside the housing and at it is fastened to hub with bolt through shaft flange. So as you can see here, this is the axle casing, and in between axle casing and hub, there are taper roller bearings which are arranged back to back, and shaft passes through the center of the casing and it is attached at the end to the hub. So here, as you can see, the side thrust is taken by the hub and thereby the bearings. Then vehicle weight is taken by the hub and thereby the bearings and ultimately axle casing. And the power or torque transmission alone is performed by this axle shaft in this case. As you can see from this construction, we'll see it in the detail here. So how the load distribution takes place? As we can see in the diagram that is on the previous slide, vehicle weight is taken by the hub and axle housing. Side thrust is taken by hub and the axle housing, and torque is taken by axle shaft. So axle shaft has responsibility of torque transmission alone. So let us see what are the advantages of this type of axles. First, as the axle shaft transmits the torque only, the size of the shaft for same torque capacity will be significantly smaller. Second is easy axle shaft replacement. No need to remove the wheels. So in the event of axle shaft breakage, the shaft replacement is very easy and no wheel replacement, I mean wheel removal is not required. Third is breakage of axle shaft stops torque transmission alone and wheels remain intact in place. So in this type of design, as you can see that the Wheel is attached to hub and hub remains in the place in the event of axle shaft failure. So the only function that stops is the torque transmission. So vehicle will stop moving from its stationary condition, but there will be no any issue like separating of the wheels from the vehicle. So as a result of that, the fourth advantage is of course higher safety in this design. And fifth is use of taper roller bearing give very high side thrust capacity. So since we are using the taper roller bearings has capacity to take the radial as well as axial loads. So in this case, we have the advantage that high side thrust load capacity is available in this case of axles. So what are the disadvantages? The disadvantages is higher number of parts, higher overall cost, and use of taper roller bearing require two set of bearing in each wheel end. So these are the uh, disadvantages in case of full float axles. What are applications? Most of the heavy commercial vehicles use this kind of design. Next type, this is the three-quarter float axle. So how is the construction in this case? This design lies between the full float and the semi-float type. In three-quarter float rear axle, a single bearing is mounted between axle casing and hub and shaft is fastened to hub. So this construction is actually a hybrid of the semi-float and full float. Here as you can see, this is the axle casing, this is the hub and this is the shaft, and there is a single bearing which is fitted in between the hub and the casing. So in this case again, what happens is the vehicle load or the tire reaction we call it. This is taken by the hub and thereby through bearings it is passed to axle housing, and side thrust and torque transmission that is done by the shaft. Here you can see the load distribution. The vehicle weight is taken by axle housing. Vehicle side thrust is taken by axle shaft and torque is taken by axle shaft. As we can see here, the axle shaft takes two kinds of loads and vehicle load is taken by hub and axle housing. So as we know at the beginning, we have studied that there are three kinds of load. One is vehicle weight, second is vehicle side thrust, and third is the torque. So in the first case of the axle, that is semi-float, all the kinds of loads are taken by the shaft alone. In the second case, two types of loads are taken by the hub and only one kind of load is taken by shaft. And here shaft takes two kinds of load, that is side thrust and torque, and the vehicle weight is transferred to the housing directly. So this is a hybrid kind of design in between the semi-float and three-quarter float. So what are advantages of this design? Axle breakdown is less in this case compared to semi-float. Unlike semi-float design, there is no chance of wheel separation from vehicle. Safer design as compared to semi-float. What are the disadvantages? Even though it is better than semi-float type, it is not as robust as full float type. So uh, it involves actually more cost than the semi-float axle, and it is actually quite closer to the full float axle. So three-quarter type of design is many times not preferred. Wherever possible, the designer will directly go to then full float. So applications seldom use in some old type vehicles. not much use in nowadays vehicles.